Hey everyone, my name is Marsha Pierce. I am the Director of Solutions Architect here at Pure Storage. This is my 5th pass, and I am here today talking to you about standardizing your environment, leveraging infrastructure as code. And this is something I'm kind of a little bit passionate about, as I did this in my past life as a data architect. So encourage everybody, maybe this is your first pass, maybe this isn't. Coming to Pass Summit changed my life. So make sure that you get involved with your local user groups. You attend a SQL Saturday, join in the virtual groups, go to the Pass Marathon. I was saying 5 years ago, it changed my life. I was a director, the senior solutions database architect at a company, and I came to Pass Summit because they wanted me to recruit and get out there and get to know other people in the SQL Server community. And I had kind of been on my own. And I went to my first Pass Summit, and somebody introduced me to Argenis Fernandez. Actually, Paul Popovich, who works for Microsoft now, actually introduced me to a whole bunch of people. I had no idea who anybody was. And it's kind of funny because Argenis and I now work together. So it does change your life getting involved in the community, and it's a great opportunity to learn. So I encourage you guys to go ahead and do that. Some of my best friends are from the SQL Server community. They're great people here. So again, I am Marsha Pierce, the Director of Solutions Architecture at Pure Storage. You can find me on Twitter at Marsha Pierce DBA. I intermittently tweet. I also have a blog site that I intermittently update. It's marshapiercedba.com. That was the best thing I could come up with at my first summit. It was a terrible one, but I picked Marsha Pierce DBA because everything else with my name was taken. But I have been a database architect. Actually, I should update that. This was like a long time ago. I've been about 25 years now that I've been working with databases. And it is true that I drove a lot of VMware admins and storage admins crazy. A lot of the guys that I used to work with at companies, I actually now see kind of working on the manufacturing side. And it's funny because I was always up in their business about their VMware configurations, their storage configurations, and how that broke a lot of my stuff. So kind of passionate about that kind of thing of infrastructure. So today we're going to talk a little bit about containers, right? That's kind of leading into the different infrastructure deployment models. Then we're going to talk about what you need to do to kind of, I guess we talk about codifying your environment. What should you do for your environment to set it up to leverage infrastructure as code? And then we're going to give a quick demo of Terraform and Ansible spinning up a SQL Server database. I don't expect anybody to be a Terraform admin. That's not what we're going to do here, but we're going to talk about what you need to do as a data professional to make the use of a infrastructure as code environment and what you need to change on your side to leverage that kind of code. So let's talk a little bit about containers. So just, I hear a lot of people talk about containers. There's lots of new terminology coming out, and I hear people get confused. They're like, is it Docker or Kubernetes? Well, Docker really is the kind of the container engine. You're in the SQL Server world. So it's either, like Docker or Rocket. SQL Server doesn't really do Rocket, so you're going to do Docker. But what you're going to use is a container orchestration, right? That is just the kind of base form of the deployment model is Docker. And then you can use different orchestration tools to deploy those containers, right? These orchestration tools are going to manage what server you're sitting on, how they're balanced, right? It's kind of the load balancer for those containers. And so you have Rancher, Docker Swarm, right? Kubernetes. So when you usually hear Docker or Kubernetes and you're confused, that's where it comes from because people are using the Swarm, the orchestration engine. And then of course there's Red Hat OpenShift. But that's just one kind of layer of this kind of layer cake approach that you have to like the containerization of data. You also have application managers, right? There's ARM and Keel. Keel was the one I used last year in my demo, but that when you maybe have a SQL Server container, that is a package, right, that you're going to deploy out into your environment. But those are generic packages. When you modify those packages, right, for your environment with the settings and how you want them to look for your particular environment, you have to hold those in a repository somewhere. And there's also Portworx, which the company I work for just acquired, that does this as well for database as a service. So these are different application package managers that you can use to then manage and make sure that, excuse excuse me, all your databases are consistently deployed across the same way because they're leveraging the same package, right? They take just a few seconds to spin up. But then on top of that, right, you're going to deploy a database, right? That instance, but that's an empty instance. You're going to want to do other things. So you're going to have to orchestrate that at the application layer with code deployments, right? Different things. And there's all kinds of tools. I think most people have heard about Ansible. That's a big one. They may put some of those repositories into GitHub. There's Adulation Software, which has Jira, CloudBees, Jenkins, Subversion. All of these have been tools you may have used in the past. Some of them are new, but that is what you're going to use to then deploy the databases, the code, the different things that you're going to have into your container environment. So these all work in orchestration together. It's usually not an either or, it's an and conversation. Which one of these am I going to use? And there's lots and lots of choices depending on what you're using. Visual Studio is one, that's easy to use. A lot of people are kind of in that world already. And when you think about containers, why is that important? Things that are, have came out last year, big data clusters, which is in part container-based software, right? It has a SQL Server, as you can see, that's sitting kind of on top, but that underneath there is a whole Kubernetes layer that is handling all those connections to those different data sources and pulling data. There was a scaling issue out under that. And so they were able to scale that connectivity out into individual containers for all those connections. And that in conjunction gives you kind of this ability to query data in place. And unlike linked servers that you may have used in the past where, all that data is pulled back and then you kind of run your analysis against that as it's pulling the entire data set across the wire, that big data clusters will let you push that query down onto the server and just retrieve the result sets. And then, of course, CI/CD pipelines. That's the biggest reason I think that most people are leveraging containers today. It's not the only reason, but it is the most common reason that people are leveraging CI/CD pipelines. And I think this is a really good reason. I ran a lot of continuous integration shops. I was in the early days of continuous integration, right? Agile development. We were one of the companies I worked for was a big contributor to that movement. And one of the biggest issues that we had, right, when we were trying to figure out how to do continuous integration with stateful data sets, there wasn't a whole lot out there on that. Spinning up applications is easy, but that stateful data makes it very hard. And we looked at lots of different methodologies for doing that. And we had continuous integration for QA, dev, test. The thing that we never got at the time that I wanted to, and I think this is a great story because I now work with them as a customer, was that we wanted the ability for every developer that we had, and we had, about 100 developers, to have their own playground where they weren't stepping on each other, right? They had branching issues. And so using a unified dev environment, they were kind of stepping on each other. But when we tried to stub out synthetic data sets for them, that also had issues because they needed to look at different types of data, right? It's not just about writing a query. You might have different types of data that are going to skew the results and what you're working on. That's very important when you're doing development. And we looked at spinning up lots of virtual machines. But when you talk about spinning up an environment for a dev to work in with tons of virtual machines, that is very, very expensive, right? And so that CI/CD pipeline, leveraging containers, that company now actually does. When we kind of saw the stuff coming along with containers, and some of the storage stuff that was coming along with that, we reached out to them, and they are now a huge customer running containers, and they contribute a lot to the container movement. And then the other thing I like that is coming out, right? Azure Arc. If you haven't heard about it, right? We all heard about Azure. Lots of people are looking at Azure. Azure, I think, there's still this hybrid cloud thing that's going on, but people have, a lot of their production data still on premises, but they want to do dev tests. They want to not have to worry about spinning up a whole lot of different things on premises for just that reason, for that CI/CD pipeline. And Azure Arc, if you're doing that in Azure, that's a really good story, right? That you can do all your development. But what if you want to do that on premise, right? If you have the need to do that instead of up in the cloud, then you have to build your own environment. Well, Azure Arc lets you run Azure on-premise, and that is a container-based software. So that is why, some of the reasons why these things are important, but all of that is at the application layer, right? So when you're in the cloud, the thing that people like is they get away from infrastructure, right? So containers let you abstract the application layer. When you're in the cloud, you've got that kind of abstract at the from the infrastructure, but there's still some things that you have to do depending on how your infrastructure is set up, even in the cloud. So how can you get that same kind of agile, decoupling your infrastructure, but then automating your infrastructure, right? People like the fact that containers spin up quickly. VMware, VMs, whether they're Hyper-V or VMware, take a little bit more time to boot up, but also that consistent configuration across them, that uniformity is a little bit more difficult. There have been ways to do it for years. And I worked for companies that did on-premise cloud solutions where we standardized, but it was a hodgepodge. And we'll kind of talk about what that looked like and what were some of the hurdles that we had when we were doing that. So I think, infrastructure as code builds on the idea of containers. So when you look at, let's take a look. If you haven't seen what a container does, this is the idea of you being able to kind of spin up a container really quickly. And this is a singular container. We're doing it manually. We're not, having a lot of automation. We'll get to that later, where we spin out a whole slew of containers from an automated fashion. But this is just me manually building a container, right? And it's code. Instead of me having to do the install of SQL Server like I had to do and trying to maybe slipstream a update in there and then making sure we have a uniform configuration file, I have a package that we have configured with the settings that we need, and we were able to quickly deploy that. Now that is an empty data set, which is why you want to look at some of those other tools to deploy your application and manage that application. But this is me with my empty data set, creating a database, right? That's what you have to do. And so this is me manually doing it, but then you can use some kind of repository to then deploy your code. So we've got the FT demo database, and now we have our table that we created with our data, right? We'll let this finish up, and you can see that I'm going to run my little select statement to show you that there's some data sitting in here in this database that we've created, right? But now we're going to do something else. We're going to go ahead and stop that container. And once we've stopped that container, we're going to remove that container, right? So you can see that the container's in a stopped state. And now we're going to go ahead and, restart the container. And when you stop that container and restart it, you haven't removed the services. So when I go in here, you can see that all of my data is still here, right? Because I stopped the container. All I had to do is restart it. I haven't lost anything. But when I remove the container after it's been stopped, and I go back in and I try to redeploy that container, right? Will I still have my data? Right? Let's take a look. So it takes just a few seconds to redeploy that container. But when I go in to look at my data, I've lost all the data that was attached because that's set outside of the container, container itself. That was just a little object in the container. When we redeployed, we lost that. So we have to think about different ways of managing these databases. So a lot of times what you're going to do is then have an external volume that sits with that containerized data. This is going to become important later when we look at infrastructure as code, but you're going to want to persist that data that you have from maybe your production environment, from a QA environment, back into that database, right? So here again, I have a containerized environment. So what we're going to do is we're going to go through my production environment, and I am actually just at the storage layer really quickly. Through code, I am going to make a copy of this data set, and this will build on the final demo that we give today. So now I have taken my production data set, which is, I think, sitting around about 3 terabytes, and I have cloned that out. And now that I have done that, what I'm going to go do is I am going to go through and make sure that I don't have any containers in my environment, right? And then once I have done that, I'm going to spin up a brand new container. And in here, you can see what I am doing is I am taking that clone of that volume and I'm mounting that outside directly into the container. So I'm attaching that mounted volume into the container. And this is a really large data set, but because I'm just attaching that clone of that data, it is going to be super, super quick for me to spin up this whole test system from just a few seconds, right? It's not leveraging that backup and restore methodology. So now I've got this data set in here. When I refresh, right? And I go look at that FT demo database. Let's go look and see how large it is. See if I remembered my disk size yet correctly. Yeah, 3.2 terabytes. So just a few seconds, we were able to quickly provision data into this environment. Right? And this is the code that you would leverage to use a mounted volume. And this will be important when we look at the infrastructure portion of that, right? So these are the basic commands that I use. I'm not going to go through them all, but it's like how to pull a container, how to run a container, you know, how to like view your container and remove a container. But whoop, I think I went back. But that's kind of important that you look at that. Now, when you look at what you're going to be doing, you want that same kind of thing. Maybe for your production environment, maybe for your dev and QA, you want that same lightweight feel at the infrastructure. Let's talk about the infrastructure deployment models. Now, why did I become passionate about having standardized infrastructure? I worked for lots of large enterprise companies, and I always loved it. You know, you go work for a really cool company and you think life is going to be wonderful, and they're doing all the cool things, and then you get a look at the environment and you find out that how are logins? Somebody asked Ryan, how are logins, jobs, and packages taken into account? We're going to get to that. That was just the data set. So we'll get to the logins, the jobs, and the packages in just a second. But I would go look at these environments. And I thought, you know, these people know what they're doing. Things are going to be great. And it was always a hot mess, always, because people, right? People are awesome. So always had dealt with lots of inconsistency in our environments. Even if we had some parts of the process automated, they weren't fully automated, so they were still people dependent. There was a lots of handoff between teams, right? So those teams could have done things in an automated fashion. They could have not. It just wasn't really consistent, right? And then what happened to my currently deployed environments? I'm sure everybody's had this where you deploy an environment, you know that you have followed all the exact steps. And maybe somebody was troubleshooting something. They weren't quite sure what they were doing. After hours, this is particularly more of a problem as you work with larger teams, and they've made a change to the production environment, right? How do you track that? What does a good environment look like? When I remember in particular, one shop that I went into, they were having performance issues, and we were trying to track down what the performance issues were because they vary depending on the environment, right? This was, think about this, it was an application that had been deployed 180 times. So I had 180 different instances, right? Standalone servers that all matched. So each application had its own set of web servers, right? They all had 20 web servers. They all had this amount of indexing servers, and they all had their own database instance. And when I went to go look at them from the database layer, the OS was not consistently configured. They were supposed to be at the same software level from the database, like the code that was deployed to the database, that wasn't consistent between the 180 environments. They were not configured the same. So what does a good environment look like? Those were some of the problems we had, right? And when you think about how we deployed code, when I first got into IT, we were all these bare metal environments, right? We would do these huge planning projects. I don't know if you've ever had the joy of being involved in one of these 5-year projects where we kind of like scope out the hardware we need. We're going to figure out what kind of ERP package we need. These are the ones that took a long time. And maybe by the time we did the initial scoping, our requirements have changed, but you have to like project growth. And it was not, these very expensive. And so it wasn't easy to kind of move around and shift. You had to do long-term planning. And if you did an acquisition or a merger during that time, that could invalidate what you've deployed to. So then, in the early 2000s, we started doing virtualization. This is some of that answer, because now still not as quick to deploy, right? It still makes it some time to deploy. When virtualization first came out, it was still very much kind of a manual process, but at least in some ways you could scale up and scale down that environment, right? You could have a little bit more uniformity. And then we just saw containers. Containers is getting us that kind of application layer. We started looking at on-premise cloud solutions back here in the virtualization stage and even applying that to our bare metal, but we'll talk about some of the difficulties of that. But now we have containers and people saw that and the cloud going on, and we're like, well, what can we do to get that same kind of environment going here? And that's really infrastructure as a code to get the same kind of agility that you get with containers into your infrastructure environment, right? And so, we talked about this a little bit, lots of 5-year plus processes sometimes for these systems are going to sit around. I'm sure some of us have really old bare metal systems sitting around that nobody wants to touch, right? Nobody knows how to reinstall that software. Maybe something's expired on it and it's just sitting there because nobody wants to touch that thing because nobody's familiar with that application anymore. It was deployed so many years ago, right? And you have one team installing the software for the operating system, one team installing maybe the network configuration, one team installing the software, and there was all this handoff between teams, and you were waiting on a backlog of people. And when we did these kinds of processes, each team had their own steps that they do. Maybe you got lucky and the operating system team was using a ghosting of an image, and hopefully that was correct, right? And that got deployed. But then you might be slipstreaming your SQL install, but there were still lots of things that you had to do from the configuration. And so we would have these huge Excel spreadsheets that we would go through. And at this phase, what we tried to do was at least automate the SQL install, right? And that was even a little bit tricky with clustering and things like that. But we would slipstream our packages and then write code. And this is actually before there was even PowerShell. So we were writing all this VB code, to try and automate the installs and then run a whole bunch of SQL configuration files to make sure that we were deploying these environments. With virtualization, it does become easier. You're still not getting as much equipment. You have to do long-term planning for growth. They still stick around for a long time, but at least, hopefully you were getting the whole OS from a template so that all your SQL servers are, were deployed from the same Windows template. Most of the time when you were doing this, you still had to manually install SQL Server. There wasn't usually a pre-prepped clone. We did actually move the first time we really kind of started to standardize. We did actually pre-prep and have an installed version of SQL Server that we kept, that we deployed from, right? So we could clone that out. But that entailed us always making sure that that clone, right, system was sitting up, that it was getting updates, that we kept it patched, because not only did it have the clone for SQL Server, that was our basic one, but we also had the application on there. So we had to keep the application and code intact. So if we ever had to redeploy the system, it had the latest updates in there. So, and still lots of hands-on between the teams. And some of the things were like not as easy to do in that process. That became a little bit easier with things like vRealize Orchestrator, but that's expensive. It is a tool, that doesn't help a lot when you're talking about jumping from, and somebody asked, can you reverse engineer a configuration installation to Terraform and Ansible? Yes, absolutely. So when you talk about these things like Terraform and Ansible, you're going to be leveraging some of the tools that you have been using for many, many years in the past, because they are letting you codified. Think of it as a kind of a control plane for working with lots of different things. Like vRealize is great, but what if you have bare metal machines in your environment? So I did a lot of on-premises, but we had vRealize Orchestrator for our VMware environments. And then we had UCS Director for our physical environments. And so we were trying to leverage and make sure that they were using the same code, but we had to deploy the code to both sets of the environments. So Terraform is going to give you kind of that same kind of thing. And what was one of the other questions? Could you create images with SQL on Windows with integrated security, or is it only SQL on Linux? We found that the only tool that supports images with SQL on Windows is Windocs. Oh, so you're talking about Windows-based containers, I am guessing? Yeah, that's pretty much it. Containers is Linux-based, right? So when you're talking about, you can easily integrate Windows security into Linux. That's been around for a long time. Leveraging LDAP. I worked for many companies that were heavily Linux-based, and we had integration in between our LDAP and our Windows Active Directory where things replicated between. So you can absolutely do that. So if security is the reason why you are trying to go to Windows-based containers, shouldn't be. There's plenty of ways to work around that with integrated replication between the Active Directory domains and LDAP. But yes, hopefully that answered your question. But again, these were hodgepodges of when we were doing the Be Realized and the UCS Director. They're great, and it's getting us closer. But there were some things, and they're vendor specific too, right? So things were changing all the time. And then we would have to change our code, and everything wasn't API based back in that time. And then, like we talked about, containers, right? Those deploy in seconds. They're great. You can use those application managers to kind of standardize those deployments. Windocs is kind of an all-in-one application manager. But again, you're using a Windows-based containers. Some of those have limitations because most people, I think that's a kind of, I don't know anybody else besides Windocs that's doing any kind of development in the Windows-based container world. Microsoft is heavily focused on Linux-based containers. Azure Arc is Linux-based. Azure, right? It's Linux-based. These are still, the containers are still mainly used for CI/CD pipelines, but I have seen people start to play around with them. I was talking to somebody, so somebody was talking to me about if you guys have ever leveraged like Kofax, these little tiny databases that maybe the application vendor wants you to have your own instance of SQL. So we were maintaining these tiny little virtualized instances that were way overpowered. People are starting to look at maybe leveraging containers for those. They're not mission critical systems, and that's what they're using them. People are also leveraging them to spin up lots of SQL Server instances, maybe that are kind of churning data so that if they kind of go down and they can come back up and pick up where they left off of. But those are some of the things to think about, you know, when you're looking at those kind of containerized environments. Stick to them mainly for CI/CD pipelines, but it's a really good way to kind of think about where you're going. And I think there's going to be a really quick adoption, right? And then when you look at like the infrastructure as code, because you have this uniform control plane, right? It's not, and we'll get into this a little bit more, it's not an either or conversation. It's letting you standardize your server build between physical, virtual, and kind of containerized environments, making sure you're using the same commands over and over again, right? It can be bare metal, it can be cloud, it can be kind of sitting anywhere. You're leveraging APIs to automate tasks, so you're not having to go and figure out each vendor's way of doing this. A lot of these infrastructure as code platforms have hooks into other vendors, and you're going to work with one of those vendors who are on that qualified list, which everybody is pretty much working on. Then because everybody has done their portion, right, and you have a unified control plane, it is eliminating the time, and you're automating this for handoff between teams. One of my biggest frustrations when we used to have kind of this really automated VMware environment, I told you that we stood up, right? Our portion of the deployment, once they had spun up our clone copy of the database, we had to expand some volumes, right? We had to add memory and CPU to it. We had scripts to do that. We also had a script to deploy the configuration for the environment, right? So if we deployed to a new city, we did an acquisition, we did lots of mergers and acquisitions, which is why we had 180 of these. We could do that in about 2 hours. It took about 2 hours for the entire code set to run to spin up a new environment. All we needed them to do was to clone out the VMs. But that still leveraged somebody actually manually kicking off the clone process and watching it run on that side. And I swear to God, that guy was always on vacation. Sometimes I'm like, I've been waiting for 2 weeks for him to clone out that environment. It is so quick, but I was waiting on people. So this eliminates that handoff between teams, right? And now you know you're deploying in a standardized way, because maybe that guy chose to manually clone it this time. Sometimes you use the automated process. You know you're leveraging the same process over and over again. So what are some of the infrastructure deployment things that you can use, right? So there's Terraform, right? Terraform is the one that we hear a lot about. Then there is Cisco Intersight. This replaced UCS Director. So that's an example of infrastructure deployment automation that is happening at the bare metal layer. You have vRealize automation, which is happening at the VMware layer. And then SaltStack, and then Portworx, which is a company that my company recently acquired, which does kind of container-based infrastructure, right, for containerized environments. Does some other things as well. That same kind of infrastructure automation. But what if you have a mix? Because I am guessing that nobody is all in on one. And if I were to even pick places where I work, we would have been a mixture of bare metal, of VMware, and containers, right? That is going to be the standard. So do you want to code up 3 different ways of managing your infrastructure? And that's where things like Terraform and SaltStack kind of play in, because they will be the orchestrator for all of these, so that you can reuse some of your code. You can have the same kind of deployment methodologies. Maybe you're leveraging something up in the cloud. Maybe you're doing AWS, Azure. So it hooks in, and that you can do the same deployment no matter where your data set sets. If it's on bare metal, it's fine. But then on top of that, you want to have, and I did not mean to advance slides, configuration management, right? So you're going to deploy your infrastructure. But now, once you've deployed that infrastructure, right, these are setting up your networking, your DNS, your hard drives, right, your compute. That's what the infrastructure deployment is doing. But now that you've done that, you got to have configuration management. And configuration management is really important. And people are using tools like Chef, Ansible, Jenkins, Puppet. True story, I actually worked with the 2 guys that founded Puppet. They lived in Nashville for many years before they moved out to Portland. I can tell you infrastructure change management became really important to me, because before they founded their own company, they were playing around a lot with stuff, and they broke a lot of stuff in my environment. I love their product. I think it's great. But in their early days when they were playing around, we worked with the same company. I would come in and be like, what happened to my environment, right? They were trying to standardize the configurations across the environment. And of course, SQL Server was configured much differently than the rest of the Windows environments. These infrastructure configuration management tools let you define, right? These are database servers. These should be how they're configured, right? How many times everybody hopefully knows that your VMware, right, or physical environment, the power plan for SQL Server should be set to high performance. It affects the performance of the machine negatively if it is not. Almost everybody knows that. I can tell you, I meet with customers all the time. They're having a performance issue. We always check the power plan. They always tell me, I know better. I haven't set that. It's only true about half the time, because people, right? It's not automated. So we all know what should be done, but when we rely on people, those things fail. So having these infrastructure configuration management tools are really good. They also kind of reduce the amount of time that you spend. I mean, I don't know about you, but we wrote this whole repository. We're pulling in server configurations, Windows configurations, right? SQL Server configurations, and checking them and having to maintain this platform that did the configuration management. Not only do these tools deploy your configuration settings that you should have, but they actually will tell you when things are out of compliance. Maybe you need to have an exception. Maybe you have some kind of imaging system that insists that you set max DOP to 1, right? So you can add exceptions into that, but you know when things fall in and out of compliance. And that is also really important, because things do fall in and out of compliance, right? So if we weren't really kind of clear what Terraform is, it is not the only thing that you are going to use. It is something that you will use in conjunction, right, with other tools. It handles the really low level components that haven't really kind of lended themselves to automation, right? You're spinning up tons of containers all the time, right? And you've got your Kubernetes platform, your Rancher platform, load balancing those. But as developers, right, are spinning up more and more of these containers, they're going to be having to add infrastructure to that to maintain that environment, right? So the fact that you can quickly spin up that infrastructure as it's coming in and not waiting weeks, months for everybody to get their configuration done becomes really important in these agile development environments. But it's also important in your production environment, right? Some of the best things that we ever did was standardize our infrastructure deployments, automate them. It leads to a lot less production issues. We even standardized the kind of hardware we were buying, right? We weren't an all one shop, but we had a very limited list because before it was whoever wanted what. And we were affected by bugs and patching, right? Because every model has its own sets of bugs, and that becomes kind of wieldy to maintain. So as you can whittle that list down, the less you're going to be bitten by those bugs. So keep in mind, these infrastructure tools are not an either or, it's going to be an and, right? And you're going to use something to unify your environment and deploy code. But the question is, are you going to be the one managing that? And it's not, but you're going to be leveraging it. So how does that affect you as a data professional? So let's get into some of the ways that this affects you as a data professional and things that we saw in our environments when we were creating these infrastructure as code environments, right? So codifying your SQL Server environment, what do you have to do, right? First of all, you have to define standards, right? You're going to be automating these environments and you have to set a standard. You should be able to go under SP configure and figure out what your standard, I'm gonna get something to drink, environment looks like. And I will tell you what I have found managing thousands and thousands of SQL Server instances and talking to hundreds and thousands of customers. Outside of memory and CPU, there is really not a whole lot that should be different in your environment, right? Everything that I did to maximize the performance, like power settings of my production environments, didn't hurt my lower environments when I did them. So making sure you set a really good standard is a common thing, right? Common autogross, common max text replication size, so that you can check them. When you have variances, what happens is when you go to deploy a new environment, it's hard to determine should that have been set or not. Is that going to affect me? Having a really large max text replication size, if you had to increase that for one server, is not going to hurt the other servers when you go deploy that. The only other thing outside of memory and CPU, and we'll leave drive configurations, right? Your databases are going to be varying size. Outside of that really is the max degree of parallelism. You will have different requirements depending on the server, right? That it needs to be set to. And that is fine. You can load that into a configuration file. We had our imaging systems that almost always, because they used this process called dipping and they used locking to control access to images, which were stored external to the database, could not parallelize their queries. So that had to be an exception that we set in our template when we were doing these checks. So that is one of the things that you really need to. Documentation standards, coding standards, right? All of that is going to become important, but that's just the tip of the iceberg. So when you automate databases, right? Instances, servers, containers, spinning them up, spinning them down, what are you going to call them? What do they mean? How do you know what belongs to what? So this was something that we tackled. What does that naming standard look like, right? So this is kind of some examples. I came up with what we used in our environment, and we'll go through it. There is a limit to the amount, how long your name can be. 15 characters, that's what you got. Technically it's 16, but one's reserved, so you got 15. So What we came up with was that we have different data centers. How do you tell? So we're going to get, how do you standardize across environments if your production SQL servers on Windows, VM, and dev and test on Linux containers, right? So your container, right, is going to have a configuration, right, that you have set. That is going to be deployed in from that container, from that application manager. Your configuration manager like Chef or Puppet or Ansible, whatever you're using, can do that check to make sure that everything falls in line. So you have a configuration manager that is doing that deployment. And you can even, I think, use that configuration manager to manage some of your repositories that you create for those templates for your containerized package. So you can have them kind of check each other in the same way. There's going to be some exceptions, right? But we did this with our physical environment before there were these managers. We did it manually with PowerShell, was that we ran checks and we made sure, and we dumped the Windows Server configurations that we were looking for, and we dumped the SQL Server configurations, and we compared them every day. So it's kind of the same thing that your configuration manager is doing it, but it's also deploying it. But we leverage those same scripts that we had for deploying for checks. They kind of automate that process for you. They know what it should look like. They can build a template of what it looks like, and they can build a template to see when it falls out of compliance. So that's pretty cool. Part of this is going to be important is knowing what environment is what, right? You've got production, you've got QA, you've got dev. Maybe you have a slight different configuration. Maybe there's a different memory and CPU. This was the big thing that was different between us and these environments. We had different minimum memory and CPU requirements for these environments. How do you tell which one is what? So one, we started off with the first half of the name, and I should have, now that I'm thinking about this, highlighted this. If you look at the first 3 letters of all of these names, that is the city in which it sits. BNA, I live in Nashville, got the Nashville skyline before me. That is our airport code. ORD, Orlando. HOU over here is Houston. So that was our data centers. And we did, you can figure out how you want to tackle it and what you want to do if you have multiple in the same city. But because we had limited data centers, I mean, we had like 8 data centers. We ended up doing BN2. That was just what we did. The second part of this right here, if you look and see, we've got WPLP, Windows production, Linux production, right? Maybe this is your SQL on Linux server right here. This is your production Windows SQL server. BDC, what is that? That stands for Big Data Clusters. That would be, we came up with a 3-letter acronym for the application, right? Sure, we all have an ERP, and something that requires web servers, application servers, and different things to work in conjunction. It may be important to make sure they're all backed up together. Maybe you want to know what an environment consists of. So you have to be able to have a way of identifying that. And as I told you, we had lots and lots of these different environments. So we were like, well, I don't know, whatever happens if we ever go to one in more than 99 in a data center. But I could have 99 SQL servers for the O1 environment, right? Because as I spun up a new location, right, that would have its own set of web servers, app servers, and database servers, that would become the O2 version of that for that BDC, right? Whatever, you know, ERP O1, right? ERP, the second ERP system, O2. And then SQL O1, SQL O2. Our data warehouse, not very like nice, but we called it RPT O1. Then we had a really good idea at any time, if I wanted to figure out what X location was, we knew that its acronym was BNA, Windows or Linux production. Either one of those would work. But in the data center, the BDC01, all of that went together. So if we had to codify and spin up a new environment, we knew what it should look like. Are we missing a server from that environment? We knew, right? Because we had the acronyms, they were all uniformly named. If we had to back them up with application consistent backups at the same exact time, which a lot of applications require you to do, we didn't have to worry anymore about missing a server because we had standardized our names in a way that we could automate what everything was called, right? Then when I want to make QA and dev servers, I know what has to match, right? All I have to do is go in here where I said Windows production, it's now Windows Q, and I had a 1-for-1 match. And I actually now know how data has to move down in this environment. When you start doing some agile development, you have to move data down in between the environments. And this for L, right? And maybe we would make these container, right? Come up with an acronym for your container-based environments for your developers. But setting the server naming standards are really important. The other thing that's really important when you do this is having a standardized drive structure, right? Whether it's a QA, test dev, a physical machine, or a virtual machine, when you're going to start automating the deployments of these and making sure production matches QA and test dev, they have to have a standard drive layout, right? Just like everybody else, we were dealing with legacy issues, so we would do new builds going forward and making sure that as we made changes to servers, these applied to the standards that we were setting, so that when maybe we finished all of our deployments or whatever time we had, there was less to clean up, but you have to start somewhere. I realize that not all of your servers are going to be configured with the drive structure that you need, but you have to start moving to it, right? Your folder layouts need to be the same because you're going to start automating where you put things. You're going to start automating adding files to servers, right? Because what we started doing when we standardized our build, when we got a ServiceNow alert that we were low on drive space, right? We monitored, we made sure we had that 20% overhead that everybody should have. But what happens when something goes awry and I'm quickly filling up on space? It was hard for me to get somebody to the computer fast enough to address the ticket. So the first thing we did was actually we either added a drive or expanded a drive automatically because APIs and infrastructure is code. And believe it or not, helps a lot with outages. We had a lot less outages. So, sorry, drives, right? We had the C drive for every machine. Every machine had an E drive, which was our software. We leveraged mount points. So we would have, right, SQL 01. That is where we were going to install our databases, right? We had some kind of name, right? And then we might have our system databases because we kept those on the software hanger because we weren't really worried about that. For the most part, the system database is set there, but we wanted people to be able to find them. So that was the other thing. We were trying to make sure we were backing up system databases. They were all over the place. You got to have them in a uniform location where you can then automate because people are going to be spinning these up and spinning these down, right? As it becomes easier to deploy, you got to make sure you have a process that is going to be able to identify this no matter where it sits without scrolling through every single drive. So you got to automate where this stuff is. So that's part of it. But remember how we talked about that container and you're going to want to take your production data set, maybe a copy of that into that container? What is your production data set made of? Maybe you know, maybe you don't know. This was a good way for us to define where our production data set is. And this is one thing that we did that maybe you don't want to do. There was a time that you had to kind of take the temp with you. Now a lot of people take temp locally, right? So temp can go now, I would say, either under E or under X, but we kept a little hanger file. We call it hanger because like these were 1 meg files. We didn't want anybody putting anything on X. But we created drives. And the standard drive that every server had, and there was a minimum size, was a data 01 drive, a log 01, a temp 01, and a backup 01, right? They had the software hanger, right? The software drive here, actually it was just that, the E drive was our software drive, it wasn't a hanger. I don't know why I put that on there. But then we had this. So we had, the maximum drive sizes that we could go to. And this is how we started making sure that our physical and virtual machines were configured the same, that we could automate from both our Cisco UCS director, which is now Intersight, and from our VMware, some of the same scripts to define these drives, right? Maybe they were slightly different between UCS and VMware. And this is where having something like Terraform, which has plugins to both of them, becomes helpful, because then you can use the common API call and it now detects that you have both and you can define these drives. But now when I have to add a second drive for data, right? Data's growing, need a second drive. I don't have to think, well, what are we going to call that data drive? What if I run out of space? How is my really small database going to be compared to my 10 terabyte SQL Server instance, right? Mount points were the way that we went. And that really helped standardize that. But under those mount points, the other thing that we did, because people suck as well, like maybe there was something they were trying to do, the alarms didn't go off and they were automating, we made sure we had a standard backup data and log drive on every single folder, right? When you went to that, where the data sat, there was always a backup data and log directory. Now, like I said earlier here, backups should go under the backup directory on backup 01, but we have all seen where somebody had an out of growth log file, right? And they had to go put it somewhere, or they needed to temporarily move a backup to do something and they just put it somewhere. So we had to tell our software, where are you going to go and look for backups? So when we create that folder structure under every single mount point that we put under this hanger, we know code-wise we can recursively go to any data, log, or backup directory, and they really should only be in backup, and look for backups here. When we want to make sure that we're including in snapshots, like from the storage side, all those files, or that we're excluding things from getting scanned from virus scans, we can say that if it's in a data or log folder, those are always excluded. So those are some of the things that we kind of did to make sure that we were standardizing our deployments. And I know it seems really obvious until you worked in an environment and you try to figure out how to get this done. The other thing that we did was we really made use of our backup folder. It wasn't for backup. So somebody says, how do you know what jobs to get, what users to get, and what other things do you need to get from your production environment to spin up into a container, right? Not all of that is stuck in your Subversion code repository, was what we used, or Team Foundation. They don't put all of that stuff in there, right? So this is what we did, was that we had scripts and processes that dumped our always on configuration into a folder in the backup directory. Backups had one for every database, right? We had our CDC, our config files, our SP configurations were dumped in here. Our DR plans actually sat on the backup drive, right? When we restored a server, right, that would get restored, but then the steps we had to take after that were in that DR folder as well. We kept them other places, but that was, if you ever had to touch a server, right, something had gone wrong, you might have to recover a database, all the steps for that were in here. Indexes, right? This became kind of important. Indexes, as we added them, we put them in here so we knew the date they were added. As we dropped indexes, we had a folder in there for indexes we had removed. We had our jobs folder, and we'll touch on jobs in a minute. But replication, right? Everybody's got, if you've done replication, locked in their pre and post scripts, we put those here. Any scripts we use for automating environments, users, right? We kept any dropped users. We could easily drop users. We had a place to script them out and put them. It was in our backup folder. It got backed up. That also got replicated to DR, and we stored stuff in here. And this became important for automating environments, because now if I want to go and take and do what I did on this server to my QA system, I know all the stuff that I have to run, and it's sitting over here in this drive in a single location. And that makes it easier to pick it up and code. Other things that you have to think about when you're going to be automating and spinning up databases and copying them different places, your data needs to be clean, right? You can't have DBAs putting their store procedures, their things that they're doing all over the place, right? So we created, I've called it different things at different places depending on what they had, a utility database. Anything that we did that was a maintenance job, any data collection that we did, for our repositories. This happened here first locally on every machine, and it was stored in the utility database. Junk databases, one of my favorites. Apparently Kimberly Tripp likes the name as well. But everybody's had users where they need you to extract data out, or they want to write something temporarily that doesn't need to stick around, like those little tiny extracts. Maybe you're doing an upgrade, you're doing some analysis. That goes in the junk. It's not part of my utility jobs. I want those to be clean and be the same, because I'm going to be doing code comparisons, right, for my repositories to make sure that all of them are at the same code level. And we had the same thing deployed into those utility databases. It will be, we also codified them so that jobs ran differently depending on the table level data, not modifying stored procedures. So having that utility, right, I could pick a copy of that database up anywhere and restore it anywhere. So I had the same utility store procedures that I could then use to run the jobs. Junk, right? That was data that we weren't going to have to keep around long term. So that prevented it from being stored in my databases. I could clear it up. Another one that we did, if you've had vendor-based code or you've been asked to replicate a system, these two are kind of really important because we're going to do some automation with replication, right? But how many times have you seen users add stuff to a database that you're replicating, right? And then you have to rebuild the replication and they lose their tables or something else happens? Not great. So we never let users write anymore to replicated tables. The replicated tables maintain the name of their original table, right? Whatever it was, database. And then we put an underscore rep. So if they wanted to do some analysis on the replicated data and store it in there, that's where it went. They wanted a view that looked at the data differently, it went in there. The only thing that we ever added in there to that replicated database that they might need that was different were indexes, and that was stored in our pre and post replication script so that we knew where that was at. And then the other one is vendor-based apps, right? We needed processes that augmented vendor-based apps, but we weren't allowed to touch them. How do you know what goes to what? People were storing that all over our system. So we came up with, for example, let's say big data clusters, and you want to write something that references the big data cluster database, right? You would call it BDC and put underscore something. And we use the acronyms for my companies in those so that you had code that went along with that application. That becomes important, right? When you're going to move that database to another server to do some testing, you now know what you have to take with it. When you move this replication someplace else, you now know what has to go with it that you've augmented that your users are going to want. And that becomes really important when you're automating your infrastructure. The other thing is when we talked about that utility job, right? And being data driven from the table level, maintenance tasks have to be what I call inclusive and not exclusive. Meaning a lot of people specifically say what they're going to want to do to stuff. And you should define your policies in a way that say, I am doing everything. And if you have an exception to the rule, it's everything except this. And they should be driven by tables. They should look at the data in the tables. Because as these agile environments spin up, we've all seen this. People add new databases. They don't get the new tasks. You spin up a new container environment. Do you want to have to go set up those maintenance tasks? Or should they automatically get everything unless you've told it not to do something, right? So those will help you with your code because you now can uniformly deploy the same maintenance tasks everywhere. And if there's a difference, it's at the table level, right? And you can back that table up and move it, but it's not going to be every time you deploy a new environment, you have to recreate the wheel. So that becomes very kind of the things I like to do. The other thing is jobs, right? You're going to be picking up your jobs and moving them. And jobs, when you start automating and moving jobs in between servers, whether it's for a migration or for replicating and making sure the same jobs move between server A and server B. I got some screenshots from my friends. I had to reach out to people because most people I work with don't do these anymore, but we all know looking at what is running in our jobs usually is a nightmare. There are tons of disabled jobs that haven't been running that people have deployed that you have no idea what it is. Don't know. Some of them, like this one, have not been running for a long time. Sometimes you have all these that like constantly failing. Does it need to run? I don't know. Hasn't ran in years. Maybe it is. I don't know what they are. So I encourage everybody to remove unscheduled, disabled, and jobs with the schedules disabled. And I've got the query here for you, but that will clean up your environment so you know which jobs can be picked up and moved when you replicate an instance. But there's other cleanup you have to do with your jobs to make sure you know what they are, right? So this will identify which ones you need to move. How do you move them? Well, what you do in your jobs folder, you've got your current jobs. So you can script those out. Those are the ones that have to always be redeployed. Remove jobs. So when you find those jobs right back in here, right, disabled, scheduled, you right click on the job and you say script, what is it, drop and recreate. And you put that in your remove jobs folder. So you can safely remove a job, but get it back if somebody like did something they shouldn't have. Like I've seen that happen, like where they're like complaining because they removed a job and somehow they knew that happened, but their job hadn't ran in a year. And then versions. That's the other thing. Like, I don't know why there's not really versioning for job unless I've missed something. There's not been any versions for jobs. So I told my guys to stop changing jobs without drop and recreate to a new one, to a version, so we knew what the job used to look like. But when you do that, what you have is a really clean thing, hopefully of only running jobs now. You've gotten rid of all the other jobs. Now you need to do some cleanup on those jobs. Because how do you know what goes with your, let's say, big data cluster database or your big data cluster application versus another thing? So what we did was we prefixed every job if it referenced a database, and this was after us like, trying to figure out what database it was going to. We prefixed it with the database name. Then after the database name, we prefixed it with the application name, right? We didn't have to completely change the name of the jobs, but you just prefix the current job with those names. And now when I was going to go do work on my FT demo database, I could easily query, or I'm going to move that to another server or codify that, and I need to start that on another server. I can identify what is affected by the FT demo database, or maybe my big data cluster application. These are the jobs that go with it. Takes a little work, but when you start automating things, you need to do that. And so I love this one. If you look, this actually came from Kevin Klein. And I got the link to it. Look, they did exactly this for Century One, right? They're all prefixed with their database names. Now, if these were me and these were SQL Century jobs, I would prefix these now with DBA maint, right? Because these are maintenance jobs. They're not specific to that for that application, something running against that. So that's how it will be slightly different. But that way, what goes with what when you have to do maintenance. I mean, how many times? And when you have all your jobs running, by the way, you can create custom alerts when jobs haven't ran in X amount of time. They're no longer scheduled because somebody did maintenance and forgot to turn them on. It actually saves a lot of headaches. So I think I am kind of running low on time. So the last thing I want to show, how does this all happen when it comes together? Well, now that I know what data sets I need, because I can codify it, right? And I've got a physical SQL server, right? And now I'm going to take that and spin that out into a container. This is an example under the, by the way, leveraging my Ansible environment that has Terraform underneath, that's doing the infrastructure as code. I am going to create a table in my production environment and now take that over to my containerized environment and kick that off with a script. And this is what it looks like, right? And when I go down to my other environment and do a refresh, the cool thing is that I have my new data moved over to my containerized environment really quickly. And I have what I need, right? And so that is the cool thing about doing this with infrastructure as code. You are not going to be the guys that are maintaining your Terraform environment, but it is going to affect you from spinning up these environments. So you have to think about how you're going to codify your databases, right? So that you can automate what's going against them and identify what you need. I did this at 2 different companies. By the way, you're going to do this in steps. Don't do it all at once. Somebody I worked with, because we did it very successfully at a company, took a new job and thought he would take all of our scripts and tried to randomly deploy it at another company, and actually met their DBAs, and they were not happy because there are nuances in your environment. So you're going to have to change those to work. So slowly roll them out, right? We started a little bit at a time, tested it over and over again in dev. When it worked to dev, we moved up. It's really easy to get this working, but if you don't do it in a slow and controlled fashion and you have an error, you're not going to get buy-in. So make sure that you do this in a controlled fashion, lots of testing when you're working with your teams, right? You're not going to automate your production of deployments at first, right? For SQL Server, that when you get to that, you're going to do test dev first. Did that answer your question to the guy that asked me, how are you going to do this between VMware and the bare metal SQL servers? That Chef Puppet can automate some of those SQL Server installs that are going to use the same configuration files that your container did to build that template. And that way you have it consistent because you're using that configuration checker across all of those environments. And believe me, it's a lot easier than what I used to have to do when I had to build all that myself to manually use the same hodgepodge of scripts. So this is a little bit of information about how you can, do a session evaluation. This is my contact information. You can always reach me at Twitter. I'm going to give you lots of time to scan the QR code in case you need to. What other questions do we have? Well, now I'm going to ask Jazit, how many people do we have?
Hi, Marsha. So you've done a great job of answering all of the questions that were coming in. You actually beat me to the punch in seeing them and addressing them right away. So that was great. And it's been a great session. So we'll just wait a little bit to see if any more questions pop up.
Oh, did not mean to do that. I think we already did that. I was just checking to make sure there was nothing else. I'll just leave it up here on the thank you slide because we did the Explorer Everything PaaS has to offer. No, the QR code is now up there. You're welcome, Juliana. And I can't even. Is it Arif? Hopefully that's right. I'm glad you enjoyed the session. All right, I'm good. Thank you guys for taking the time to listen to me today. If you do have any questions, just feel free to email me, marsha@purestorage.com, and I will be happy to answer your questions. Oh, I do have a question. If I have jobs running SSI packages, can you deploy these in containers? No. I don't think SSIS packages run in containers yet. I think that is still one of the things that is missing. The last I looked, but that's one of those things that I didn't do this time. I usually check before I do these sessions because that changes all the time. I remember that when containers first came out, you couldn't run jobs. I was like, well, that's crazy. But you could absolutely run jobs now. But yeah, no, SQL Server reporting services, I know for sure does not work with containers, and I don't think SSIS does either yet. But it's coming, I'm sure.
All right. Thank you, Marsha, for a great presentation.
All right.
All right.
Thank you.
All right.
Bye.
Bye.